Welcome, young mathematicians. Today we're going to continue our lessons from the last session on integers. We're going to learn how to solve equations. Before we get started, I would like to review you on some of the information that we covered last time. So if you have your counters, get those out. If you remember last time, we started using counters. So can you use your counters to represent the number 3? Remember, you don't have to have fancy counters like mine. You can always make your own counters. If you remember last time, we discussed how you could make them out of pieces of paper. Notice how on my little pieces of paper, some of them are marked as positive and some of them is marked as negative. In this situation, I have positive 3. So there are 3 yellow dots. If I were using my homemade counters, I would have 3 of my homemade counters. The next thing that I want to remind you about is how we represent those negative numbers that we saw on the counters. How would I represent the opposite of 3? Notice how on my counters they're going to be red. So positive 3 we represented with 3 positive numbers. Negative 3 was with these 3 red counters. Now this is important because I want to remind you of a term that we talked about the last time. And that term was called a zero pair. Remember that zero pairs are things that add up to be 0. So in the example that we just did, if I have positive 3, negative 3 makes it 0 pair because a positive plus a negative 1 creates 0, positive 1 plus a negative 1 creates 0, positive 1 plus a negative 1 creates 0. So a positive 3 and a negative 3 form a 0 pair. If I gave you the number negative 2, how would you form its 0 pair? What would be the other number that you would need? I'm going to give you 4 seconds to find the other counters that I should pair with this to make a 0 pair. Did you put down 2 positive counters? If I have negative 2, then positive 2 is what forms its 0 pair. Negative 2 plus positive 2 forms 0. This is important because the last time I had asked you to consider subtraction as adding the opposite. So when we think about subtraction as adding the opposite, it allows us to use 0 pairs. This is an important idea, so please don't forget this. It's going to make solving our equations much easier. So let's get started. These first set of equations are going to involve addition and subtraction, and they focus on content that's in the grade 6 master course lessons. Those solving equation units came earlier in the year, but now we're reviewing. So this should look a little bit familiar. Let's see if we can stretch your minds back to that time. In this situation, I have what's called an equation. Do you know why it's called an equation? If you said it has an equal sign, you're right. An equation is a mathematical sentence that has 2 expressions that are equivalent or equal to each other. I have an expression on this side and I have an expression on this side, and they're equal. So that means whatever's going on over here is the same quantity as what's going on over here. So let's represent these. Now remember, I want you to use our strategy that we've used before in the past about noticing and wondering. When I look at this equation, what do you notice and what do you wonder? So let you take about 4 seconds to notice and wonder about this equation. What are some things that you notice? What are some things that you wonder? All right. Did you notice that there are some numbers in the equation? And did you notice that there's a letter in the equation? What? Where are these letters coming from? And how are we going to represent that? Now remember, we always start with stuff that we know, stuff that we can do. Always start there. So when I see my 3 plus x equals 9, I know how to represent the 3 and the 9. So let's do that first. So 3. Oh, it's positive 3. So I put down my positive 3 counters. And then on the other side, I have 9. And it's positive. So I'm going to put down 9 counters that are all positive. I know how to do this. That's a good thing. Oh, but I was wondering, how do I represent that x? It's an unknown quantity. And in math, we call it a variable because it can be all sorts of different things. I'm going to call a bunch of them x, but it could be all different values. So an unknown quantity like this, what we're going to use today is we're going to use a cup to represent the unknown variable. Now, if you don't have a little cup, you can use all sorts of things from around your house. If you wanted to, you could use like a small box to represent the x. And remember, right now we're just going to use the cups instead of the box. This approach to solving equations is called in cups and counters when you're talking to your parents. So we're trying to figure out how many counters should be held in this cup so that this side of the equation is equal to this side of the equation. What am I gonna do? Right now, can you think to yourself, if I have 3 here and I need to have 9, how many counters should be in here? Are you thinking? All right. So what I'm trying to figure out, I think that if I already have 3, in order to get 9, I would add 6 more. That's what should be represented by the cup, are these 6 numbers. But I just guessed that, and there has to be a better way to do this. Let me think about this. So one way to think about the equations is that right now, I've got some counters on this side, and I've got some counters on this side. It would be helpful if I have all of the counters on one side. So how can I get rid of a positive 3? Oh, I'm going to give you a hint. Ding, ding, ding. Do you remember that one of the things that we reviewed today was called a 0 pair? How can I form a 0 pair if I have positive 3? That's right. I would put in negative 3. But remember, in mathematics, we are not math gods, so we can't just randomly add in a negative 3 on this side. We also have to add in negative 3 to the other side of the equation. That's an important thing to remember in mathematics. In order to maintain this equality so that they stay equal to each other, if I add negative 3 on one side of the equation, I have to add negative 3 to the other side of the equation. And guess what? What are those? What are these? This forms a 0 pair, goes away. This forms a 0 pair, becomes 0. This forms a 0 pair, it becomes 0. Same thing on this side. It forms a 0 pair and becomes 0. Forms a 0 pair, becomes 0. And this forms a 0 pair and becomes 0. And I am left with my cup, or my x, my variable, all by itself. We call that isolating the variable. And we're left with our 6 counters. 1, 2, 3, 4, 5, 6. So indeed, this matches with what I guessed earlier, that x is equal to 6. Shall we try another one? Let's try m plus 3 is equal to 5. So again, let's start with what you know. I'm going to give you just a second to see if you can set up the equation with our models, with our cups and our counters. Let me give you about 5 seconds to try to set that up yourself. All right. So I'll start with what I know. I can put 3. I'm getting really good at 3. All my examples have 3's in them. And then I can make the 5. And then do you remember how we represent our variable m? With our cup. So remember, this side of the equation is equal to this side. That means everything that happens over here has the same value as this over here. And I want to, in our last part we learned about isolating the variable, I want to get the variable all by itself. So I need to remove the counters from this side. And we had a process for doing that. And that was to use our 0 pairs. So I have positive 3 right now. What are the 0 pairs that I need to introduce? Y'all are excellent. Negative 3 is the 0 pair that I represent. And if we wanted to write that down, we would write minus 3. I need to try to use a marker that works. Negative 3. That's the 0 pair that I'm introducing right now. Negative 3. But remember, we have to maintain our properties of equality. You can't just subtract 3 on this side. Remember, I've already told you, you are not a math god. So we're going to add in our negative 3 on the other side. We're going to add in our 0 pair. Again, 0 pair becomes 0, becomes 0, becomes 0, and I'm left with just my variable or my cup. Becomes 0, becomes 0, becomes 0, and I'm left with just 2. So m is equal to 2. My variable is equal to 2. And some of y'all may have been able to guess that 2 plus 3 is equal to 5. But today we're going to stretch beyond just these 6th grade one-step equations. We're going to make them more difficult, so hang with me. All right, let's try one more. M plus 3 is equal to negative 7. And this is where the whole point of using 0 pairs makes the process a little bit easier. So let's build our equation. I start with my 3. Told you I use lots of 3's. And this time I'm doing negative 7. So remember, I've got to use the negative sides as I create my negative 7 and then my variable for m, my cup. M plus 3 is equal to negative 7. As we saw earlier, we want to use our 0 pair. You should be getting really good at the 0 pair for positive 3. The 0 pair is to add in a negative 3. But this time, I'm going to add in my negative 3. This makes a 0 pair. This makes a 0 pair. This makes a 0 pair, and I am left with my variable. I isolated my variable. But earlier, remember those 0 pairs? This doesn't make 0 pairs this time. This time, it actually adds to the total that's there. So where I used to have negative 7, 2, 3, 4, 5, 6, 7, I added in another negative 3, and now I have negative 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In this situation, m is equal to negative 10. You might notice, because in this situation, I added in negative 3. Remember, that was the zero pair portion that I added in. And notice, I have a negative 7 and a negative 3. This follows from those first sets of videos that we did where we have two negative numbers. We have two negative integers, and they combine to be negative 10. So that's some of our past learning that's showing up. What I would like to go to now is solving multiplication equations. In this situation, let's represent 3x is equal to 15. So I want you to spend just 4 seconds to notice and wonder what's different about this equation than the ones we were just doing. So 3 seconds for you to notice and wonder. This time, did you notice I don't have a plus sign? I don't have a subtraction sign. I don't have any sign. What the heck does that mean? Remember, this means multiplication. So 3 times x. And this means, 15? I know what 15 means, and it's positive. You know what? I can put 15 counters down. And remember, we always want to start with what we know how to do. So let's start with what we know how to do. I can put down my 15. Let's see if I can beat you. You may be faster than me, but I'm going to try. Okay, there's my 15. Now this says there is 3 times x. Do you remember that we were using x to represent, we were using a cup to represent our variable? But this is saying I have 3 times. I have 3 groups of x. That means I have 3 cups. 3 times x. Because I have 3 groups of x. I have 3 groups of variables. This is what 3 times x would represent. So what I have to do is I'm saying that if there are 3 groups of variables, there are 3 groups over here, how can I take the 15 and divide it up so that there's an equal number in each of these groups? So I've got to take my 15 and try to figure out how I can arrange these so that the same number goes into each cup. Well, I can see if I put 3 in each cup, I can see that, but then I got these 6 left over. Let's see here, I'm just going to put them up here. I've got 3 in each cup, and I've got to figure out how to get all 15 into each of these cups. I'm just going to add 1 each time. Let's see if this works. Oh my goodness, I think this is going to work. Look, I used all 15 counters, and I got 5 into this cup, 5 into this cup, and 5 into this cup. So that means if I have taken 3 groups of x and taken my 15 counters to put them in there, if I look at it, each cup or each variable has 5 counters. So x is equal to 5. Remember, this said 3 groups of what equals 15? What we found was 3 groups of 5 is equal to 15. So let's try another one. 2x is equal to negative 8. 2x negative, okay. Negative 8, I know how to do that. I can set up negative 8. Can you set up negative 8? All right, remember this is negative. All right, I've got the negative 8. Always start on the side that you know how to do. And 2x, this means 2 times. So 2 groups of x is equal to -8. And I have to figure out how many are in each group. So I have -8 counters. Oh, and I have to divide them into these groups. Oh, look, watch this. Look at this is how good I am. Are you this good? I bet you are. Yes. So that means if I divide the -8 into these two portions, I have 4 in this cup, I have -4 in this cup, and so that tells me that 1x is equal to -4. So this says 2 groups of x is equal to -8, and we're saying that in each group is -4. X is equal to -4. Look how we're moving through this. Is your brain hurting yet? All right, now we're going to try to solve division equations. Okay, now we're going to look at two-step equations. We're moving into the 7th grade and the 8th grade material now. So I want you to look for 4 seconds at this equation, and I want you to notice and wonder what is different about this equation compared to what we were doing earlier. So you have 4 seconds to think about this. All right, did you notice that we've got more numbers in here? So we still have one side of the equation, thankfully just has one piece, the 8, and I know how to do that. Let me do that right now with my counters because I know how to do +8. All right, now, the other side of my expression though has a lot more numbers. I have 3p, oh that's my variable. I know how to do that. I can use 3 cups. Those are my 3 variables, stand for 3p. And then if you remember from yesterday, I had asked you to remember that we redefine subtraction as adding the opposite. So I want to redefine this subtraction as adding, the opposite of +1 is a -1. Now you don't have to do it this way, but it sure makes the process a little bit easier to think about at the beginning. As you get more and more knowledgeable about solving equations, you may not have to do this redefinition step, but it helps for right now. So let's add the -1. So I've represented 3p plus -1 is equal to 8. So if you remember in our problems earlier, one way that we get rid of things or we move things around was I use a 0 pair. So the opposite of -1 is a +1. And to maintain my equality, I'm going to add a 1 over here as well. Do you remember what happens to my 0 pairs? That's right, they make 0. That's why they're 0 pair. And this doesn't have a 0 pair to make with anyone, so he just gets added into the group. Now I have 3 x's or 3 p's, 3 variables, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 counters that I need to figure out how I can get the same amount in each cup. So earlier, I was just kind of dividing them up. Oh, look! I have, if I take the 9 counters that I had and put them in each of the 3 cups, so I have 3 groups of 3. That means that 1 cup or 1p is equal to 3. 1p is equal to 3. So very quickly, I'm going to show you how I do this. Remember, we added a +1 because that was my 0 pair. That gave me 9. This created a 0 pair, so it went to 0 and I had 3 cups left over. And then I divided in my 9 so that it could go into the 3 cups. So I divided by 3. And I ended up with p is equal to 3. That's already 7th grade. Let's try one more, and I'll show you what it is for the 8th grade. In this situation, I have letters, I have numbers, and they're all over the place. Let's try to represent this very quickly. I always start with what I know, so I can represent the 4. I can represent, it's subtracting 2, so I'm going to add a -2. So I will represent with 2 of my negative counters. If I have 5p, that means I have to have 5 cups. Almost getting too many to fit on the screen. And then on this side I have 3. Now we do the same thing that we did earlier, but I want to show you something very quickly about the cups. In the similar way that we did 0 pairs with our integers, we can do 0 pairs with the cups. So what I want to show you is that if I have +3 over here, I can represent -3 cups on this side. And what happens when I have a positive with a negative? It creates a 0 pair. And that's helpful because now it will end up with just cups on one side. But remember, to maintain my equality, I cannot just add -3p to one side. I have to add it to both sides. And so we end up with 2p is equal to -2. I perform my 0 pairs on my integers. These go away for 0. I now have 1, 2, 3, 4, 5, 6, and 2p. And if I divide them up into 2 groups, I end up with each p, or each cup, is equal to 3. And so that's very quickly an 8th grade application of the cups and counters. Thank you very much for joining us today. We hope you have a great time learning how to solve equations. Thank you, and I'll see you next time.